Okay, this video accompanies the Envision Savvas Geometry 1.7 Writing Proofs problem set. And we're going to focus on some of the proofs that we need to write. So these ones I have circled, the ones we're going to do. Number 11, they tell us to write a paragraph proof, but we're going to actually focus on two-column proofs. So we're going to write a two-column proof of theorem 1.5. Given that two angles are both congruent and supplementary, then they're right angles. We're going to do a two-column proof for theorem 1.6, which is if you have a linear pair of angles, then they are supplementary. We're going to do a proof of number 18. They want a paragraph proof. We're going to do a two-column proof. And then after we do the two-column proof, if you could try to put it into paragraph form, you would have the paragraph proof. So we get given information and what we need to prove. We're also going to do number 19, complementary angles. What one measure is, and another one where it looks like we've got some complementary angles and maybe vertical angles involved. So we're going to go through these proofs. So kind of as a review, let's go over and look at our proofs that we've had so far in this section. Let me blow this up. So we have theorem 1.1 was our verticals angles theorem. Now the way these are named, this comes from chapter 1. It's the first theorem in chapter 1, second theorem in chapter 1, third theorem in chapter 1. It's better, it's best, it's important to know the name or the paraphrasing of the theorem rather than which number it is, because different geometries are going to use different numbering systems. So theorem 1.1, vertical angles theorem, all vertical angles are congruent. Theorem 1.2, if two angles are supplementary to congruent or to the same angle, then they are congruent. 1.3, congruent complements. If two angles are complementary to congruent or to the same angle, then they are congruent. Theorem 1.4, all right angles are congruent. Theorem 1.5, if two angles are both congruent and supplementary, then they are right angles. And then our theorem 1.6, the sum of the measures of a linear pair, which is a straight angle, is 180 degrees. So those are the theorems we've had so far. Now, legal maneuvers are, let's look back at here. Okay, we want to prove theorem 1.5. So anything after anything from 1.5 on hasn't been proved yet, which is not usable. So for our proof, we can use, if it applies, we could use 1.4. Right angles are congruent. We could use the congruent complements. We could use congruent supplements. Or we could use vertical angles along with definitions. So those are the only legal things that we're allowed to use as we try to prove 1.5. Only what we've proved up before 1.5. Now once we've proved 1.5, that becomes legit to use for 1.6 and so on. So you can always use theorems that have been proved before, but you can't look ahead. There's no shortcuts. So let's look back and do this proof. So remember, we have our 4 problem-solving steps that we should run through as we try to do these proofs. The first step is understand. Like, ask yourself, what are they asking us to find in this proof? Then make a plan, do the plan, and then look back, review. What did you learn? What's different? What's the same? How could you use this again? Is there a different way? So these are our 4 steps that we'll try to emphasize as we set these proofs up. So let's see what we got here. Okay, so here's our theorem 1.5. This goes with 1.5. Our theorem 1.5 says if two angles are congruent and supplementary, then each is a right angle. Now we can't use that for this proof, but basically that's what this proof is. Once we've done this proof, we will have proved 1.5, so it becomes part of our arsenal to use for future proofs that we need to work on. let's see what we have. So this is what we're given. Angle N and M are congruent. So angle N is congruent to angle M. Let me make a note off to the side. Angle N is congruent to angle M. And also the measure of angle N, since they're supplementary, the measure of angle N plus the measure of angle M equals 180. So those are the two things that we're given, and we need to prove that these are right angles. So let's see, I guess we can always start with a given, but let's try to work our way through what needs to go on with this. So N is congruent to M. N plus M is 180 degrees. So I would maybe use N plus N being equal to 180. And since N is congruent to M, then that means that the measure of M is congruent to the measure of angle N. So I can substitute one of those into this, like say the measure of angle M plus the measure of angle M is equal to 180, which gives me two measures of angle M is 180, which means measure of angle M is 90, which means measure angle M is right. And since N and M are both congruent, then angle N must be right. So something like that is what needs to be done in the proof, and we'll end up with where we need to go. So let's start with measure of angle N plus measure angle M equals 180, and that's given. Now we need to take care of getting that N and M have equal measures. They're telling us that they're congruent. That's another given we can use. Measure N is congruent, or angle N is congruent to angle M. That's also given. Now both these could have been put into number one together, but it's more straightforward maybe to keep them separate. Now by definition of congruence, we can say that the measure of angle N is equal to the measure of angle M. So that's definition of congruence. So we've got that N and M are equal to each other. Now I'm thinking replace angle N in number one, the measure of angle N in number one, with what it's equal to from step 3, which is the measure of angle M. So we end up with two measures of angle M equal to 180, and that lets us show that angle N or angle M is 90 degrees. So we're going to substitution property of equality. And we're substituting between 3 and 1. I like to note that. This means equality. And we're going to say that the measure of angle M plus the measure of angle M equals 180. So all we did there was we took this angle M, since it was equal to N, and we replaced the measure of angle N with what it's equal to. So that's substitution. Now this gives us two measures of angle M equals 180. This is simplify. And then step 6, might have to add some more steps onto this. Get black. So step 6, let me move some of this other stuff out of the way first. Let me get rid of these lines here. See how many more we can fit in there. Ahead of time, I didn't know how many steps it was going to take, so I just tried to save some space. So let's see. So that means if we divide both sides by 2 or multiply by 1/2, we've got that the measure of angle M equals 90. So to go from 5 to 6, I would look at it as dividing both sides by 2. That makes this the reason division property of equality. Now if the measure of angle M is 90, we can say that angle M is right. angle. And that would be definition of right angle. A right angle has 90 degrees. Okay, now we're going to go up here and continue our steps. So we got a number. So let's do the statement reason. And we're up to number 8 now. So let's see what we got for number 8. So angle M is right. Definition of right angle. Now, from back in step 2, we've got that angle N is congruent to angle M, which means these are replaceable. So if angle M is right, angle N must also be right. So this is going to be a substitution. I'm going to substitute between 2 and 7. So substitution between line 2 and 7. And I'm going to be able to say that angle N is right. And so between 7 and 8, we have proved that angle N and angle M are right angles. So this one took 8 steps. Okay, let's move on. Now let's look back at the problem page. So we did a 2-column proof for number 11. Let's look at number 12. Write a 2-column proof of theorem 1-6. Given that ABC and CBD are a linear pair, prove that ABC and CBD are supplementary. So if we go over and we look at theorem 1-6, after we do this exercise, we will have proved this linear pairs theorem, which makes it legit to use in the future. We can use everything up through 1-5 as a help for 1-6 if we need it. So angles congruent supplementary, then they're right angles. All right angles are congruent. If they're complementary to congruent complements, congruent supplements, and then vertical angles, and those are the theorems that we can use. So let's go to our page and see what we got here. Oh, it's the wrong page. So here we have our diagram. If they don't give you a diagram, you need to, every one of these proofs you do basically needs to kind of be rewritten separately. You need to supply a diagram. There's a given, there's a to prove, statement reason, 2 columns, and then they need to be numbered. And then let's brainstorm through this. So again, the understanding part is to ask ourselves what we need to do. Now they're telling us that these are a linear pair. So I drew a linear pair pattern here. A, B, C, C, B, D are the angles, and these 2 angles they're telling us are supplementary, which means they add up to 180 degrees. Well, that's what we need to prove, is that they add up to 180 degrees. So I'm thinking the way this proof should probably go is ABC and CBD make ABD, which is a straight angle. A straight angle has a measure of 180 degrees. So the measure of ABC plus the measure of ABD equals 180 degrees. And that means that ABC and CBD are supplementary by definition of supplementary angles having a sum of 180 degrees. So I'm thinking that's the way this proof will probably go. So let's see what we got. So we got our givens. Angle ABC and CBD are linear pair. And I abbreviate linear pair with LP just to save space. So when you see LP, we're talking about linear pair. That's given. Okay, so as a definition of a linear pair, that means that the measure of ABC, no, that means that angle ABC plus angle CBD, the measure of ABC plus the measure, let's see, how could we do this? They're a linear pair. Let's note that ABC, angle ABC plus angle CBD equals a straight angle. And this would be angle addition postulate. Now I kind of maybe skipped a step here, like ABC plus CBD equals ABD. ABD is a straight angle, so ABC plus CBD is a straight angle. So this could have actually been maybe done in 2 steps to be a little bit, to not be a little bit more clear. Okay, so let's see what we get from that. That means since these make a straight angle, that means since a straight angle has 180 degrees, that means that the measure of angle ABC plus the measure of angle CBD equals 180. And this would be definition of linear pair, or definition of straight angle. Okay, we want to get to these being supplementary. That means that since definition of supplementary is 2 angles whose measures add up to 180, by definition of supplementary, we can say that angle ABC and angle CBD are supplementary. And that would be definition of supplementary. Supplementary angles. Yeah, it looks like that's what we needed to do there. So ABC and CBD are linear pair. Got that. Because they're linear pair, that means that with angle addition, they make the straight angle. Straight angle is 180 degrees. Since those 2 angles make the straight angle, their measures make 180, because that goes with the straight angle having a measure of 180. And by definition of 2 angles that add up to 180, they are supplementary. So we've shown that they're supplementary. Okay, so that's a proof. It may not be the best proof. There may be a different way, but that's the way that I happen to come up with this time through to prove number 12. Okay, let's go back to our problems from the text. So we took care of number 12. Let's look now at number 18. They want us to write a paragraph proof. We're going to do a 2-column proof, and they're giving us a diagram with some information. And what I've done is I've copied the diagram and the information over to this page here, and we're going to set up a 2-column proof. So when I copy it over, I want to make sure I got everything in there. So ABC 114, DHE 25, ABC 114, DHE 25, EHF 41, EHF 41, ABC, GHF are supplementary. And make sure I got the diagram straightened up here. ABC, DHG, DHE, DHF, DHG, DHE, DHF. Okay, so I got the diagram set up. They don't have to be to scale, but they need to try to be close. So first thing we do is set up our statement reason columns. And what you need to do is, because there's not enough room to do these on the page, basically you need to copy all of this over on a separate page, and you also need to sketch the diagram from the book onto a separate page next to where you're going to be doing your proof, because we need to have it as a reference. And I'm going to number the steps, maybe number it through 5 and see how many we need to do. Because I haven't even really thought about the proof yet. I'm just setting it up. Okay, so let's see what we got. They tell us that ABC, this angle, is 114 degrees. DHE, this angle here, is 25 degrees. And EHF, this angle is 41 degrees. And ABC and GHF are supplementary. ABC and GHF are supplementary. That means these two add up to 180 degrees. And notice I'm missing something here. Like, what do I need to go for? Like, I left the to prove part out. Duh. Let's see what we got. Prove DHF is congruent to GHF. Prove DHF is congruent to GHF. Make sure I got that. GHF congruent to DHF. DHF congruent to GHF. Yes. Oops. So again, now we're up to this proof here, but we went up through 1/6. So all of these now are fair game for us to use as reasons for future proofs. So any of these could be used for this proof that we're on right now. It's going to be useful to have a list. I start out the list. You'll get a printout of this, and hopefully you will add to it as we go through the other theorems. There are more theorems coming. So we want to kind of keep these in order. Another thing we could have done would be to put the page number in our book that the theorem occurs on, like in case we need to refer back to it. I took these off the presentation page, so I didn't have the actual page numbers from the book. Okay, so let's see. So understanding. Okay, I started trying to label in and organize the information. Now GHF, this angle, and DHF, this angle, need to be supplementary. So this is most likely got something to do with congruent supplements. Let's go back and review that theorem, the congruent supplements theorem, which is theorem 1-2. If two angles are supplementary to congruent or to the same angle, then they are congruent. So we've got two angles. Let's say angle 1 is congruent to angle 3. So if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 also are supplementary, then angle 1 is congruent to angle 2, is what we get from the congruent supplements. So this is 114. Let's see. These add up to 66 degrees. So 66 plus 114 does make 180. That means that this DHF angle and the ABC angle are supplementary to each other. Now we're also told that ABC and GHF are supplementary. So these two angles are supplementary. So we've got that these two angles are supplementary, and we also have that these two angles are supplementary. So this angle GHF is supplementary to a 114 degree angle. This GHF is also supplementary, let's see, this GHF angle is supplementary to this DHE angle. Okay, let's rethink this. So if, let me take these out for a second. Go to gold. Okay, so ABC is 114, and also ABC and GHF are supplementary. So if ABC is 114, and if GHF and ABC, if these two angles are supplementary to each other, then that means these two angles have to add up to 180 degrees. And we can show then that 180 take away 14, since supplementary angles add up to 180, is going to cause GHF to be 66 degrees. Now they're telling us also that DHE and EHF are 25 and 41 degrees. Together, these also make 66 degrees. So we're going to bring that out in the proof, and then we'll end up with DHF of 66 degrees equal to GHF of 66 degrees, which leaves these two angles congruent with each other. So that's what we need to do in this proof. Let's see how we can do that. Okay, so let's see. Let's get all these angle measures in there. Measure of ABC is 114. Measure DHE is 25. Measure EHF is 41. Those are given. It's givens. So we got the 114, we got the 25, and the 41 in as part of our proof. Now, ABC and GHF are supplementary. ABC and GHF are supplementary. So we need to bring that in there. And then from that, we're going to get that the measure of GHF is 66 degrees. So next step, angle ABC and angle GHF are supplementary. It's given. Now, definition of supplementary means that the measure of ABC plus the measure of GHF equals 180. It's definition of supplementary angles. And let's see now, ABC and GHF are 180. Now, if ABC is 114, we have 114 plus measure of GHF equals 180. This is a substitution using step 1, which is ABC is 114, and step 3. So we got that. Let's see. So from that, we can get that the measure of GHF is 66 degrees. And that would be subtraction property of equality. Okay, so we got GHF is 66 degrees. Put that in there. Now, we see before that these two angles also are 66 degrees. We need to bring that up. So we need to say that measure of DHE plus measure of angle EHF equals 66 degrees. And this is addition property of equality using step 1. So make a note that I'm using step 1 for that. We've shown that now this DHE and EHF by angle addition makes angle DHF. So step 7, measure, change colors. Measure of angle DHE plus measure of angle EHF equals measure of angle DHF. That's angle addition postulate. Okay, let's go up here for step 8. Here are 2 columns. Need a statement, need a reason. And let's see, so what did we do so far? We've got that. So if DHE and EHF are 66 and DHE and EHF are also DHF, I can substitute and say that DHF is equal to 66. Measure angle DHF equals 66. That's substitution. And what was that substitution between? That was between steps 6 and 7. And now we've got that DHF is 66, and we also have that GHF is 66, so we can say that they are congruent to each other by definition of congruence. So for step 9, we've got angle GHF is congruent to angle EHF. And that's the definition of congruent angles. And we're using step 5 and step 8. Okay, so there may have been another way to do this, but this is the path that it seemed to follow to prove that. Okay, let's look at the problems. Number 19, write a 2-column proof. This goes along with example 4. Angle 1 and angle 2 are complementary. Angle 1 is 23 degrees. If angle 1 and angle 2 are complementary, then that means that angle 1 and angle 2 together make 90 degrees. And we'll see what else goes on with that. So let's go over to our page. Make sure, okay, so we got the 1, 2, 3 diagram. Make sure our diagram's set up right. And this is, okay, so here's our number 19. So we got to do 2 columns. Go over here in case this is longer. So you got statement, reason. Let's see, and let's number them 1, 2, 3, 4. And we'll add more as we need to. Okay, so 1 and 2 are complementary. It means this makes a right angle. They add up to 90 degrees. Now 2 and 3 are supplementary. One and 2 are complementary. If 1 is 23, then a measure of angle 2 is going to be 90. Since they're complementary, they add up to 90. It's going to be 90 take away 23, which is going to be 67. So angle 1 is going to be 23. Angle 2 is going to be 67, since these need to add up to 90 degrees. And we also, from the diagram, can see that 2 and 3 together are a linear pair, which means they're supplementary, which means they add up to 180, which means that angle 3 must be 113 degrees, which is what we want to prove. So let's see, again, let's kind of recap how this needs to go. So angle 1 and angle 2 complementary. Angle 1 and angle 2's measures make 90. Angle 1 is 23, which means angle 2 must be 67. Angle 2 and angle 3 are a linear pair, which means measures of angle 2 and angle 3 are 180. And then 180 take away 67 leaves measure of angle 3 equal to 113. So that's pretty much the order that I think this proof is going to go in. So let's see what we got. Okay, so where to start? Let's start with angle 123. Let's do the angle 1, angle 2 complementary first. Angle 1, angle 2 complementary. It's given. That means that the measure of angle 1 plus the measure of angle 2 equals 90. Definition of complementary angles. Now we need that the measure of angle 1 is 23. It's given. Notice that your givens don't always have to be at the beginning. You can use them as you need them, like playing cards. Now if I substitute in, I have 23 for the measure of angle 1 plus measure of angle 2 equals 90. That's substitution. And that was between steps 2 and 3. Let's extend this on a little bit further. Step 5, 6, 7. Okay, so we got that. Take away 23 from both sides. Measure angle 2 equals 67. And that's subtraction property equality. Take 23 away from both sides. Subtraction property equality. So we got measure of angle 2 is 67. Okay, now from the diagram, angle 2 and angle 3 are a linear pair. And let's look at our theorems for a second. Where's the linear pair one? Theorem 1.6, linear pairs theorem. The sum of the measures of a linear pair is 180. So we're going to use this theorem 1.6, the linear pairs theorem, to go from linear pair to 180 degrees. Okay, so let's go back. So angle 2 and angle 3 are a linear pair. And again, I'm abbreviating linear pair with LP. That's definition of linear pair. Now there's where that theorem 1/6 kicks in. Measure of angle 2 plus measure of angle 3 equals 180. And we don't want to use the theorem name, but we want to say linear pairs theorem for a reason. And maybe I would note that's our theorem 1/6. So linear pairs theorem lets us say that they're 180 degrees. Now angle 2 is 67, so we're going to substitute that in, which when we subtract it is going to leave angle 3 equal to 113 degrees. Okay, so step 8, let's go over here for 8. Go up here. So we get 8, and then 9, and maybe we'll have 10. That statement, reason. Let's see what we need for number 8 then. So 2 and 3 are 180. Now I'm going to substitute in that the angle 2 is 67 degrees. So we're going to have 67 plus measure angle 3 equals 180. 67 plus measure angle 3 equals 180. That's substitution. And where did we substitute? We substituted from 5 into 7. Subtract 67 from both sides. Measure angle 3 equals 113. Subtraction property equality. And we got it. So we didn't need step 10. And we got that one. Okay, let's go back. So we did number 19. We got number 18. Now we have number 20. So number 20. Given the measure of angle 2 is 30 degrees. So kind of brainstorm here a little bit. Measure angle 1 is twice measure of angle 2. So that means twice measure angle 2. That must be 60 degrees. This is going to give us a right angle here. By vertical angles, angle 2 and angle 3 are congruent. It's our vertical angles theorem. And angle 1 and angle 4 are congruent. So if the angle 1 and angle 2 add up to 90 degrees, since they're congruent to 3 and 4, then 3 and 4 must also add up to 90 degrees. So that's how this proof is going to need to go. Let's look and see. So for this one, let's see, you got vertical angles theorem. Vertical angles are congruent. We're going to need that to go crossways. Congruent supplements, no. Congruent complements, no. That doesn't apply. Right angles are congruent. Probably not. Both congruent supplementary and linear pair being 180. So looks like on this one, the vertical angles theorem for sure we're going to use, and possibly right angles congruent, which is our theorem 1/4. Just kind of, thinking ahead here a little bit. Let's look down here at the bottom. Okay, so got to do a 2-column. So we got statement. Let me change colors. Reason. This one might not be, we'll see how long it is. It's hard to predict. I want to make sure all the steps logically follow. So let's kind of think about what's going on with this one. Angle 2 is 30 degrees. Angle 1 is twice the measure of angle 2. So we're going to be able to show that that's 60 degrees. And then angle 1 is equal to angle 4 because of vertical angles. Angle 2 is equal to angle 3 because of vertical angles. So I could say that Yeah, okay. So this is how this should go. Show that angle 2 is, well, angle 2 is 30 by given. With the other given, we're going to be able to say that angle 1 is 60. Therefore, 1 and 2 are complementary since they add to 90, which makes them, well, they add to 90 degrees. But also at the same time, 1 is congruent to 4 and 2 is congruent to 3. So when we substitute that back in, we're going to have from 1 and 2 being equal to 90, we're going to have 3 and 4 being equal to 90 by substitution. So let's see if we can do that. So let's do measure angle 1. Well, measure, let's get all these in here. Measure angle 2 equals 30. Measure angle 1 equals twice measure angle 2. It's given. So from that, we can say that measure angle 2 equals 60. And this is a substitution. What we did was we substituted twice 30 into there and got 60. It's a substitution using step 1, which is our givens. So we got measure angle 2 is equal to 60. Now, might as well get the vertical angles in here. So angle 1 is congruent to, let's go back. Now, see, I want to say that they're equal to each other, but let's go back and see what the vertical angles theorem says. The vertical angles theorem says that vertical angles are congruent. So I'm going to have to say those angles are congruent, and then since they're congruent, their measures are equal to actually get the measures part in there. So let's say angle 1 is congruent to angle 4. And also angle 2 is congruent to angle 3. And that's our vertical angles theorem. Now in other geometries, that's our theorem 1-1. In the past, I have taken an extra step and said that angle 1 and angle 4 are vertical angles, and angle 2 and angle 3 are vertical angles. Therefore, angle 1 is congruent to 4, angle 2 is congruent to 3 because of the vertical angles theorem. So we're just expecting whoever's reading this proof to recognize that what the vertical angles theorem is and look at the diagram and see that 1 and 4 are vertical angles and 2 and 3 are vertical angles. A better proof might have as an extra step to note that they are vertical angles and then use the vertical angles theorem. Now, if we have that, that means that the measure of angle 1 equals the measure of angle 4, and also the measure of angle 2 equals measure of angle 3. And that's a definition of congruent angles. So we've got everything we need now. Now if we show that 1 and 2 together make 90 degrees, we're going to substitute in from step 4 into that, and we'll have that the measure of 3 and 4 is also equal to 90 degrees. So measure angle 1 plus measure angle 2 equals 90. That's angle addition. Postulate. And for step 6, we're going to substitute for measure of angle 1, measure of angle 4, and we're going to substitute for measure of angle 2, measure of angle 3. So we're going to say measure of angle 3 plus measure of angle 4 equals 90. And that's substitution using, what did we use? We used step 4 and step 5. Okay, let's kind of look at the flow of this proof then. They're giving us that angle 2 is 30 degrees. Then from that, we got that angle 1 was 60 degrees, since it's double the measure. Then we have that by vertical angles, 1 and 4 are congruent, and 2 and 3 are congruent, which means that they're equal to each other in measure. And the measure of 1 and 2 makes 90 degrees. And then when we substitute back in, we got the measure of angle 3 and the measure of angle 4 also equal 90 degrees. And we did the proof. Okay, so we also have the proof for number 20. Okay, thank you for going through these. These proofs are, not the easiest. The more you think about the logic and the connections, the easier they're going to get. If you try to avoid thinking about these at all, they're always going to be difficult. The more you do, the more when you do the looking back, you're going to have steps that you're going to know worked in previous ones, and it'll just give you like intuition, and these should not be any harder as we move on. Okay, thank you.